All right, guys. So today we're going to review one of the sample exams. This is the final for fall 2014, 2015. So there were 3 questions that you could not answer from here. So we're going to have 3 additional ones at the end instead. All right. So we start from question 4 because the first 3 should have been skipped. Okay. So we have a monopoly. The airline knows that there are 2 types of travelers, the business kind and vacationers. So for a particular flight, there are 100 business travelers that are willing to pay $1,600 for a ticket, and there are 100 vacationers that would be willing to pay $500 only for a ticket. All right? The plane has 200 seats. And the cost to the airline of providing the flight is $150,000. Right. So basically what we have here is no variable costs. Right. They're going to pay $150,000 anyway for the plane, no matter how many passengers there are on it. Okay. So the first question is, if they cannot price discriminate, how much profit will they make? Well, if they cannot price discriminate, they need to charge only one price. So what are the available options? What's reasonable for them to charge? They should either charge $1,600, right? In this way, they're going to capture the business travelers, all right? Or they should charge $500. In this way, they're going to capture everybody, right? So now we need to see which one gives them the higher profit. And the first question is, what is that profit? All right? So they're going to do whatever is best for them. We need to analyze both scenarios. Because under some conditions, even though they cannot price discriminate, they'll be better off picking up everybody, right? So we need to see. So let's say first, if they, we know the total cost is going to be what? $150 no matter what, right? So total cost is set at $150,000. So then we're going to have 2 scenarios. At the price being, what was it, $1,600? Then the quantity sold would be what? 100, right? Because then only the business travelers will board the plane or buy a ticket. So total revenue would be then $160,000. Agreed? All right. And then profit under this scenario would be? Well, profit is total revenue minus total cost, right? So total revenue minus total cost, which is 160K minus 150K, which is 10K. Right? That's one of their options. The other option is to charge a single price of $500, and then this way they're going to capture everybody. You understand that there's no point charging anything in between, right? So they shouldn't be charging anything between $500 and $1,600, because then they're still going to pick up only the 100 business travelers. And anything below $500 also doesn't make sense, because that gives them no other travelers. So the other option, when they cannot price discriminate, would be at a price of $500, but that everybody's going to pay that price now, right? So total cost is still $150. What is total revenue in this scenario? Oh, it's the $500, and then you have how many travelers? 200 now. So they make $100,000. Now with that total revenue and that total cost, they're actually going to have a loss, right? So that scenario they're not going to follow. So profit under this would be -50, right? So this is not the case. However, if the lower willingness to pay was high enough, like if it was, for example, $1,000, so we still have different willingness to pay. We have $1,600 and we have 1,000. If it were 1,000, then this would make it 200,000, and the profit would be 50. So they would actually charge that, right? They would still make more money if they were able to price discriminate, but under that scenario, then they would go with the lower price in equilibrium or in the beginning. Now, we know this is not going to happen, so that's not a reasonable course of action for that airline. What they're going to do if they cannot price discriminate is they're only going to charge $1,600 for the tickets. They're going to capture the business travelers, and they're going to make a profit of $10,000. Agreed? So the answer would be 10,000. The next question is related to this one. and it is how much additional profit can the airline earn by charging each customer their willingness to pay relative to charging a single price. So this is the first scenario. So relative to this scenario, how much more can they earn if they are able to charge customers what they're willing to pay? So basically, we will charge the business travelers $1,600, but we will also charge the vacationers $500. And then we'll fill the plane, right? So the question is how much additional profit? Well, the total cost is still only $150K, right? So the profit with price discrimination would be, well, they're going to charge $1,600 the business travelers. They're going to charge $500 the vacationers, and they're still going to pay only $150K because that's the only they only have fixed costs here. So pretty much this minus that was our profit before, right? You see that in the original scenario? So the extra that they're going to get is just that, which is 50,000. All right? Do you have any questions? So the answer here is A, 50,000. All right, question number 6. Erase. Okay, now we have perfect competition, okay? In perfect competition, we suppose the demand curve and the marginal cost of an individual firm producing in this market are given below. So this is the market demand, right? We know in perfect competition, each firm is facing a horizontal demand curve, right? So they take the price as given, and based on that price, which is also given to the equal to the marginal revenue, they decide how much to produce at the intersection between that price and marginal cost, right? Do you remember that? That was for perfect competition. So here we have the market demand, which is at any price, what quantity the market is going to demand, and this is in hundreds, so keep that in mind. And this is for an individual firm. We're given its marginal cost. All right, so at each quantity, what is the marginal cost of production? We're also told that each firm, so firms are, the assumption at first is that they're identical, and they all face a fixed cost of $22. Also assume that they can only produce integer quantities, right? So they cannot produce a fraction of the good. That's going to play a role in a little bit. So the first question is, which of the following circumstances would generate an upward sloping long-run market supply curve? All right. So we know that in perfect competition, the long-run supply curve has what shape? Not the cost. That's what you're thinking about. The market supply. In the long run, what's the supply? It's horizontal, right? Because any increase in demand would be matched by more firms entering this market, right? And if all firms are identical, have identical cost curves, then all of them are going to have a minimum average total cost that is exactly the same, right? We know that in perfect competition, in the long run, we produce at the minimum average total cost, right? The price is equal to the minimum average total cost. This is because profits need to be 0 in the long run, correct? So if there's an increase in demand, that's going to be met by just more firms entering the market, but those firms entering the market have the same minimum average total cost, so the price is going to return down to the original one. And that's why the perfect competition generally has horizontal long-term supply curve, market supply. Now, the question is, which of the following circumstances is going to induce an upward sloping supply curve? So basically, the price would be higher when the quantity is in equilibrium is higher. The solution to this basically is that when firms have different costs, right? So if some firms have a certain cost structure and others have a different one, right? So assume that some of them have that structure and others have, for whatever reason, higher minimum average total cost, right? What's going to happen is that when demand is not as high, so when there's certain quantity, the first firm, the ones with the lower minimum average total cost, are going to be producing in this market. But when you need more firms to enter, and the only available firms are the ones with the higher minimum average total cost, then to incentivize them to enter the market, you need to pay them more, right? You need to pay them that higher price. So that's why we're going to have at certain quantity, only the firms with the lower minimum average total cost producing, and then once the quantity needs to increase, the ones with the higher minimum average total cost come in, which produces the upward sloping supply curve. Do you see that? Understand the idea? All right, basically, they have different cost structures, so we do not have a single price that satisfies everybody. And actually, in the long run, then the firms with the lower cost structure are going to be able to earn profits, right? Which is not, which is an exception to the general perfect competition rule. All right. So, which of the following circumstances will generate an upward sloping? All firms share the same marginal cost schedule as in the table, but only 80 firms have a fixed cost of 22. The rest of them have a fixed cost of 30. So, would that generate an upward sloping long term? Yeah, right? Because the average total cost for them is going to be different. Right? Basically, the variable cost in this case is going to be the same, but the fixed cost is higher for some. And we know total cost is a sum of fixed and variable. So if fixed is higher than average total, the minimum of average total is also going to be higher for some of them. Then we have, so this is true. All firms share a fixed cost of 22, so now the fixed cost is the same, but only 80 firms have those marginal costs. The rest of them have a marginal cost schedule of those numbers, which are basically, if you compare them, they're all higher than the original ones. So again, in this case, the fixed cost is going to be the same, but the variable cost is going to be higher for some, which again is going to move the average total cost, the minimum average total cost higher. All right, so that also works. You can see the third one, but the third one also has basically giving them different costs. And the answer to this is D, which is all of the above. Right, as soon as you see that two of them are true, then the answer must be D. All right, any questions? It just said here in the first. Assume that that's the case. So the question was, how do you know that the fixed cost is 30? And the first answer A says, if the situation was like that some firms have those costs and other firms have a fixed cost of 30, then would that generate, if that were true, would it generate an upward sloping?
So it's nothing to do with the tables?
The question is, does it have anything to do with the tables? At this point, you're just assuming a deviation from what you're given in the beginning. All right, so just a theoretical question. Now the next one, we will move to the tables. So this is question 7. So again, we have the same information given, the market demand, the cost, the marginal cost of the firm. And the question is, so this is perfect competition, keep that in mind. If the price of the good is 17, how many goods will each firm produce? Okay, so the price of the good is 17. And we said that the perfect competitor takes that price as given and decides on the quantity that they're going to produce in the short run based on where marginal cost equals the price. All right, so for perfect competition, we know that the price equals marginal revenue equals marginal cost. So price equals marginal cost. This is the equation that we need to set here. Whatever that happens, that's the quantity that they're going to produce. So the price is 17. And marginal cost we have here. So the price of 17 actually falls in between the 5th and the 6th. However, we are told that they cannot produce part of goods, right? They only can produce integers. So what happens if they decide to produce the 6th unit? Well, for the 6th unit, the marginal cost would be 18, and the marginal revenue would be only 17. So the 6th unit is actually not worth producing. Okay? So what they're going to do is produce how many? 5. Right? And this is just because of the integer rule, right? So perfectly they would produce somewhere in between 5 and 6, but we're not allowed to do that. So what they're going to do is at the price of 17, they're going to produce 5 goods with a marginal cost of 15. All right. So the answer to this question would be A. All right. So question 8. It is again related to the same scenario. If the price of the good is 17, so the same assumption, what is the short-run profit of each firm? Right? We know that in perfect competition, we are allowed to have short-term profits and losses, but in the long run, profits become 0. So in the short run, given the price of 17, we know they're going to produce 5. All right? The question is, what is their profit? All right, so how do you find this? Well, total revenue minus total cost is one way to go, right? So total revenue here is what? For each firm, for each individual firm, what is total revenue? Sorry? Right, it's the price times the quantity produced. And from the previous problem, we know they produce 5. So for each of them, there will be 17 times 5, which is 85. Now we also could find the total costs. Right? That would give us then the total revenue minus total cost would give us the profit. To find the total cost at 5 units of production, we can actually do that right now. We can set up another column here, which will be total cost. Okay? And we know that the fixed cost is 22. So when quantity produced is 0, what is total cost? 22, right? Because there's no variable cost then. We also know the marginal cost for each additional unit is the increase in total cost that that unit brings about. Okay? So basically, if at 0 we start at 22, then the total cost at 1 would be what? 25, right? It would be the fixed cost, the initial one of 22 plus 3. So that would be 25. And then for the second good, total cost would be? Total cost. 31, right? So you just take the previous total cost at the marginal cost, and you get the new total cost. All right? So it's that plus this equals, that's 31. And then plus this equals 40. Plus this equals 52. I'm doing it right. Okay. And finally, plus 15 equals 67. Equals 67. We can pretty much stop there. For now, we don't need to calculate it anymore. So now we know the total cost at a quantity of 5 is 67. We just can subtract that from the total revenue, and that's going to give us our profit. Agreed? So total cost would be 67, and therefore the profit in the short run would be 85 minus 67, or 18. Do we all see that? Do you have any questions? All right, so the answer here would be B. And what would be the profit in the long run? Can you calculate it? 0. You don't need to calculate it. You know, right? Okay, so answer is B here. Okay, now we move to the next question. That is question 9. Again, we are in the same scenario. So if the cost of the good is 17 as before, how many firms produce for this market in the short run? Okay, so in the short run, we know some firms are making profit, but how many of them are going to produce? How can I find this? That will give us average total cost. What do we also have given as information? We have the demand for the market, correct? And I also know how much each firm is going to produce, right? So each individual firm produces a quantity of 5, right? We figured that out already at the price of 17. 5 units of the good. Now, the question is how many units would the market demand? And how can I find that? I'll look at the demand schedule. And at a price of 17, how many units the market demands? 300. 300, okay? So the quantity demanded is 300. So how many firms produce in the short run? 60. All right, so the number of firms, therefore, would be the total quantity that the market asks for divided by the number of units that each firm can provide, and that gives us 60 firms. And this would be answer A. Agreed? Another question. In the long run, would we get more or less than 60 firms in this market?
Less.
So some firms, even though they're making good money, are going to leave the market? They are going to come in, right? Because here firms are making a profit, a positive, they're winning money. And what's going to happen is other firms are going to see that, and they'll want to share in it, all right? So they're going to start entering this market, and they're going to enter, and that's going to decrease everybody's profits up until the point of 0 profits, right? That's the whole idea. So in the long run, we're going to get more than 60. Now, if they were making a loss, then in the long run, for some firms, it doesn't make sense to stay there, right? So then they would exit and we will get less firms. Again, until profits become 0. All right? Does that make sense? Yes. Okay. All right, so yeah, answer is A, as we said. Question 10. Again, the same information. What is the exit price in this market? Okay, so let me clear this up. What do we need to find to determine the exit price? Which is also the point at which it's also the point at which average total cost is minimized, right? We know in the perfect competition, well, we actually generally the marginal cost intersects average total cost at its minimum, right? So what we need to find as the exit price would be the minimum average total cost. What would we need to find if we were asked for the shutdown price? So this is the exit price, all right? So that's in the long run, when are firms going to exit this market? The answer is they're going to exit this market when they don't make profits, or when they're making a loss, all right? And the first point at which they're not making a loss is the minimum average total cost. So for the for the exit price, we need to find the minimum average total cost. What about the shutdown price? Average? Variable cost, right? It's the minimum of the average variable cost is going to give us our shutdown price. Here we ask for the average total, for the exit price, so we need to find the minimum of the average total cost. Well, we do have the total cost already calculated from before, right? So we can just calculate what the average total cost is at each quantity and see where it's minimized, right? Okay, so I'm going to add another dimension to this. That's going to be the average total cost. Average total cost is just total cost divided by the quantity, right? So for the first one, 25 divided by 1, that's 25. This is 31 divided by 2, this is 15.5. 40 divided by 3, what is this, 13.33. This is 52 divided by 4. So we see it's decreasing so far, right? We need to see where we're going to see a decrease, a minimum, and then an increase. So far, we haven't reached that point. Let's see here. 52 divided by 4, this is 13. 67 by 5, 13.4. And we can stop there. So what is my exit price?
13.
What is my exit price? That's not a price. That's marginal cost. We're looking at the wrong one. Is the minimum, what is the minimum average total cost? 13. So what is my exit price? 13. There we go. All right. And we know it's going to keep increasing here, so we don't need to keep going. All right. So the answer here would be C. All right. Question 11. All right. Same scenario. How many firms exist in this market in the long run? Well, we already established that they're going to be more than 60, but that doesn't really help here, right? Because if the answer is higher than 60. So the question is, yeah, how many firms in this market in the long run? How can I figure that out? So now think about the long run. Where, at what point are firms producing in the long run? They're producing at the point or at the quantity that minimizes average total cost. Right? We know that that's going to happen because profits need to be 0. So we know that in the long run, this is what each individual firm is going to do, correct? So basically, in the long run, the price long run is going to be $13. We know that that's where the equilibrium is going to end up being. And we know that each firm is going to produce how many units? 4. How can I find the total number of firms? I can again use the market demand. All right? So in the long run, how many units will the market demand? 900. All right? Because we know in the long run the price is 13. At the price of 13, they require 900 units. Okay? So the quantity demanded in the long run is 900. And that's all you need, right? To find the number of firms, divide the quantity demanded. So the number of firms would be 900 divided by 4, 225. And that will be answer D. Okay? Any questions?
So if you were to ask for the short one, it would be 12.
So if you were to ask for
The short one for the market.
the short run what?
I mean, sorry, to shut down.
The shutdown price? Well, I need to calculate the average variable cost in this case, and I would do that. I mean, I have the average total cost, and I know that the fixed cost is 22 for everybody. So the question is, if you were to calculate the shutdown price, how would you go about doing that? I would just set up another column, which would be the average variable cost. I'll find its minimum, and that will be my shutdown price. We have a question like that coming up. All right, answer D. Question 12, and I think we're done with this. So I can. All right. Okay, so now we have a new picture. We have monopoly, and we have the marginal cost, the demand, the marginal revenue of this firm. Actually, I want to add something to this picture. You can fix that. I just make this. I just need to tell you that this is 30. All right, so assume that that's the picture that you're given. All right, so suppose the marginal cost curve in this figure represents either the marginal cost of a monopolist or the industry supply of a perfectly competitive market. What is the loss in consumer surplus if this industry is served by the profit-maximizing, non-price discriminating monopolist, so the general monopoly case, versus if it were the perfectly competitive outcome? So the question is, what is the loss in consumer surplus? So let's look at the two scenarios and what happens under each. So if I'm a monopolist, what quantity would I produce? 100. We know monopolist is going to produce where marginal revenue equals marginal cost, which is here. And they're going to produce 100 units. And they're going to charge, however, $20. All right, this is the monopolistic outcome. What is consumer surplus under this monopolistic outcome? Well, it's the area above the price and below the demand curve. So under monopoly, and this is, again, when they cannot price discriminate. Right? So this is the general outcome. So this is consumer surplus with monopoly. And where would a perfectly competitive market produce? At what quantity? 150. So we know then the price or the demand curve equals the marginal cost curve here. That's the optimal outcome also. They produce at 150, they charge 15. All right? And then what is consumer surplus under perfect competition? Right, it's above, again, above the price, but the price is now 15 and below the demand curve. So then it will be this whole area. Okay? The question is, what is the loss in consumer surplus when we move from one to the other? And what is the loss? It's the area of that trapezoid. All right? So I need to find the area of that trapezoid, and that will be my solution. Well, we know to find the area of trapezoid, you can either separate it into a rectangle and a right triangle, or you can just use the trapezoid area formula, which was, so I'll name this loss in consumer surplus, and this is, well, what is this side? So generally, the formula for trapezoid is A plus B over 2 times H. This is A, and this is how large? From here to there, 150, and this is 100, and the height would be just the difference in the price, it would be 5. So I'm going to have 150 plus 100 divided by 2, the whole thing times 5. So this is 625. Agreed? And that will be answer D that you can't see over here, but it's at the bottom, 625. Okay. All right, question 13. Now, the same scenario. What is total surplus if a profit-maximizing monopolist can price discriminate perfectly, and there are no fixed costs? Okay, so now our monopolist can perfectly price discriminate. So basically, out of all the people that are going to buy this product, he can charge everybody a different price, and everybody exactly their willingness to pay. What is total surplus in that under that scenario? What is total surplus? It's actually, well, actually, the monopolist is going to take everything, right? There's zero consumer surplus, right? Because consumer surplus is below the demand curve and above the price, but for every point in the demand curve, they're charging them that price, right? So basically, there's nothing left for consumers. Everything goes to producers, and total surplus is just the area of this whole triangle. Yeah. Okay, so what would that be? Well, we know the height of the triangle is 150. So total surplus, this is perfect, well, this is discriminating monopolist, all right? This side, that's why I put the 30 there, because it wasn't clear, but you could have calculated it yourself, but to simplify your life a little bit. So this side, the base of the triangle is 30. The height is what? 150, right? Because they'll start here and they'll start charging right there. Divided by 2. 450 divided by 2,250 is total surplus. And as I said, this is the area of that whole triangle. Because they can perfectly discriminate. Agreed? Let me ask you then this. It's getting a bit. So, if the monopolist was not able to perfectly discriminate, all right? So we're in the outcome where they produce 100 and they charge 20. What would be producer surplus in this case? We saw that consumer surplus was the area below demand curve and above the price, right? It was that triangle there. So, right, so that trapezoid would be producer surplus, okay? Okay, now this question was total surplus, perfectly discriminating one, and that's answer A. All right, question 14. Again, same picture. What is the deadweight loss if this industry is serviced by a maximizing, well, profit maximizing, non-price discriminating monopolist rather than a perfectly competitive firm? Deadweight loss. All right, so they're not able to price discriminate. So we're in this outcome. All right, this is the outcome. A price of 20 and a quantity of 100. What is total surplus in this case? Well, it's the sum of producer and consumer surplus. This is consumer surplus and this was producer surplus, right? So total surplus is that big trapezoid there. Agreed? What would be total surplus under perfect competition? The whole triangle. All right, because then the equilibrium would be right there, and that would be the efficient outcome. So deadweight loss, right, it's the little triangle there. It's the loss in total surplus in the two situations. So it would be the area of that triangle here. This is the deadweight loss. And we know, well, we can calculate that easily. So the deadweight loss would be, what is the base? 10, right? It's from here to there. And the height is the quantity difference, right? That's 50 divided by 2, so 250. That's answer B. Agreed? Do you have any questions so far? All right. Next one. All right, so next one doesn't have anything to do with this. All right, this is just definitions. Which of the following conditions is characteristic of a monopolistically competitive firm in long-run equilibrium? All right, so now we have monopolistic competition. What did we say happens in the short run? How do they behave? As if they were? Each individual firm in the short run is going to behave as a what? Sorry? The opposite. What's the opposite of perfect competition? If there's one. Right. So a monopolistically competitive firm in the short run is going to behave as a monopolist because they have differentiated products. Remember? Right? So they have something that makes their product special. So in the short run, they will be restricting quantity, charging a higher price, right? Just as a monopolist does. However, what happens in the long run in a monopolistically competitive market? What did we say happened? Competition, right? The entry and exit happens in that market. Something that was not allowed in monopoly, which is why the monopolist could sustain the long run profits. Now, in a monopolistic competition in the long run, we do not have that condition anymore, right? They are allowed to enter and exit the market. And as they do so, the profits go to zero. Okay? So it is, if you remember the graph, all right, so we have some marginal cost, we have some average total cost, we have some, let me put this, all right, so we have some demand curve, some marginal cost and marginal revenue. We know in the short run they're going to be here, right, when marginal revenue equals marginal cost, and they're going to produce at a high price, restricting quantity just as a monopolist does. But in the long run, since those guys are making profits, what's going to happen now? Other firms are going to enter. When they enter, they take away demand, right? They take away customers. And what happens is the demand curve shifts to the left. And if I make this correctly, it will hopefully be tangent to the average total cost curve at some point, but not at the minimum of the average total cost curve, right? The minimum average total cost curve condition was reserved for perfect competition in the long run, right? That's where production happened in the long run. For the monopolistically competitive firm, they still produce at the point where average total cost is equal to the price, right? But it is no longer as well equal to the marginal cost. It is actually higher, right? So they produce at this point, which is higher than the marginal cost. So in that sense, monopolistic competition is not perfectly efficient as well. All right, so that being said, having that picture, in the long run, what condition is satisfied? Condition B, all right? So A is when we have what kind of market? Price equals marginal revenue equals average total cost.
Perfect competition.
Right, and here, price equals average total cost. This basically tells you zero profits, right? When price equals average total cost, profits are zero. Agreed? All right, so both of them make zero profits. However, those guys do not produce at where marginal cost equals the price, which will be the optimum. They produce at a point where price is actually higher than marginal cost. And what would that scenario be? Who produces where marginal revenue equals marginal cost? A monopoly, right? Because this gives you profits long run. So in a monopolistic case, there's really no difference between short and long run, right? Because there's only one firm producing. Right? So nothing really changes in the long run. All right, and that is just, but that is actually somebody producing at a loss. So in the long run, that would not be sustainable. All right? So the answer here is B. Those are some things that you should have clear in your mind for the exam, right? You should not have to think about that. This should be very clear to you. All right, the answer here is B. Okay, question 16. Now we have an oligopoly. So oligopoly, we know there's at least two firms or a very small number of firms in general. In this case, we have two of them. The table below shows the demand curve for their product. So at any price, this is the quantity that's going to be demanded. Well, at any quantity, this is the price. And this is the total revenue, which is just one multiplied by the other. All right. We're also told that each firm has a constant marginal cost of $10, okay, and 0 fixed costs. So can you tell me what the total costs would be if a firm produces 10 units? Why 90?
Well, we're going to minus $10.
Sorry?
Minus $10 cost, the marginal cost from
The marginal cost of each unit is 10. If they produce 10 units, what is their total cost? 100. Remember, total cost is fixed cost plus variable cost. There's no fixed cost in this case. And variable cost is constant at 10 per unit, right? So each of those 10 units generated a cost of $10. So in total, for however many units you want to produce, you just multiply that by 10. That's when you have constant marginal cost and no fixed costs. All right. So that being said, let's look at the. All right. We have two firms. What if they successfully collude? How much profit will each of them earn? So when we have a cartel, when they meet and make a joint decision, what do we know the outcome is going to be? Is it going to be the best that they can do? Yeah. Jointly, right? So basically, they're going to produce at the point where total profit, the joint profit of the two firms, is maximized. Correct? Yeah? So we just need to figure out where that is. And we can find the profit because we know the total revenue at each quantity. We also know how to calculate the total cost at each quantity. And we can just do that. So I'm going to add here total cost. And then since there's no, right, so then the difference would be just the profit. However, those will be the joint profits, right? So at the point where the joint profit is the highest, I know that's what they're going to do when they collude. But also be careful because this is the joint profit, and we're asked about the individual profit of each firm. So what would I do once I find that? How do I find the individual profit? Just divide it by 2, right? All right, so total cost. So now I'm going to look at the quantity. So for each quantity, I know that the total cost is just that multiplied by 10. Agreed? Now, if I had some sort of fixed cost added to this, I could just add that as well to every row. But in this case, it's 0, so just the total cost here would be 400, 500, 600, and so on. There you go. Profit. So what's going to happen with profit? Well, it's going to increase, reach a maximum, and start decreasing, right? We know that that's the shape. I'm going to look for that maximum. So let's start doing it. This is 1,600, right? This is just total revenue minus total cost. This is 1,750. This is 1,800. This is 1,750, and this is 1,600, and so on and so forth. Right, you see the pattern. So it started increasing, and now it's decreasing.
Can you please repeat how to get the total cost of 400 and the little loss there?
A total cost, right. So the question is, how did I get the total cost? Right. Total cost is fixed cost plus variable cost at any quantity, correct? Fixed cost is 0 here, so we can forget about it. So total cost basically at any quantity would be variable cost, right? Just because there's no fixed. We also know that variable cost is the area below the marginal cost curve until that quantity, for any quantity that you want. Well, my marginal cost curve is $10 constant. This is my marginal cost. So how do I find my variable cost, which is also my total cost, at a quantity of 40? Well, I know it's the area below the marginal cost, right? And what is this? Well, this is the $10 marginal cost times the quantity of 40. So it's 40 times 10. And that will be true for any quantity that you want to calculate. Right? So basically, each additional unit gives you a cost of 10. So if you have 5 units, then your cost would be 50, the total cost for all of them. Because each of them had given you that $10 cost. But this is also another way to think about it. Right? The area below, and since this is constant, right, it's just whatever, it's just the marginal cost times the quantity. So at any quantity, you can find it that way. And that's why I'm just here multiplying the quantity by 10 to get the total cost. I also mentioned that if there were a fixed cost, then I would just add that to this. And it's going to be, right, to get the total cost. And it's going to be the same throughout. So if there's a fixed cost of $100, then I would just increase all of these by 100. All right? All right. Where are we? We're looking for, well, we were looking for the maximum profit. And we already can see that this happens here. Agree? So when they collude, they're going to agree to a quantity that they're going to produce, or to a price, which is equivalent, where the joint profits would be maximized. So how much are they going to produce in total? How many units? 60 units. How many units will each firm produce? 30. At what price will they charge? $40. Right? They'll make a joint profit of $1,800. And how much would they make individually? There you go. That's all there is to it. So that's answer A. However, what do we know about this? Is that a sustainable equilibrium? Right, and that brings us to the next question. The answer here is A. Next question is, all right, so again, the same scenario. Suppose that they agreed to maximize joint profit, so they were at the initial equilibrium. However, while one of the firms produces the agreed upon amount, right, so one doesn't cheat, the next one decides to do so. They break the agreement and produce 10 units more than they agreed. Is this new situation a Nash equilibrium? Meaning that, is there any way for either party to make themselves better by deviating from that equilibrium? Right, so what we have now is basically one of the firms staying at the agreed upon, like following the agreement, and the other one cheating. What do we know is going to happen? For whom? The profits are going to be less for the one that's not cheating. And what can they do then? Cheat as well. And that's going to make them better off than the current situation.
But isn't it both cheat, the profits are going to be less?
So the question is, isn't it true that when they both cheat, the profits are going to be less? And the answer to that is correct. That's what happens. And this is what we call the prisoner's dilemma, right? If they agree to stay at the joint profit maximizing quantity, both of them are going to be better off. But they individually, when they individually analyze it, they care about their own profits. And they figure out that, well, if I cheat and the other guy doesn't, then I'll be better off, so I should do it. But the problem is that each of them figures that individually. So the Nash equilibrium that they end up with is actually at the point where none of them has any willingness to cheat or any incentive to cheat. The profits, they are lower for both of them, right? But at least they are at a rest. They don't have any conflicts anymore, right? They agreed on it. There's no way to make one of them better or the other. So that's what the outcome is. It's less efficient, of course, for the firms individually, but that's what it is. Anyway, so as we analyzed this already, so the question is, suppose that's a situation, one of them cheats, the other doesn't. Is this a Nash equilibrium? The first answer is yes, because they both continue to make economic profits. Is that true? No. The second is yes, because this is the firm that didn't cheat, profits will fall if it also produces 10 more units. Is that true?
Yes.
So it is a Nash equilibrium because they're better off deviating from it. What did we say was the Nash equilibrium? Nobody is better off when they deviate from it, right? That's the definition. Right? So given the other person's choices, they are happy where they are. So if one of the firms, the one that didn't cheat, can actually increase profits by cheating as well, then they wouldn't stay in this equilibrium, right? They will follow through. So the answer is actually, well, it's no because of that same, well, what is it? I got confused. First of all, the answer should be no, for sure, right? Because we know that that situation is not a Nash equilibrium. So it's either C or D, which we can see. I think C says no because Acme can increase its profits by also producing an additional 10 units. Right? That's the one. That's the one we're looking for. And if you were to analyze this, what problem is that? 17. Right. Okay. So if we were to analyze this situation in more detail, let's look what happens. So our original scenario was this, and then Pinnacle deviated by producing 10 units more. So under this new scenario, what is the profit of Acme, the first firm? So one of them, Pinnacle, produced 10 more, so the new quantity is actually 70. However, everybody gets the lower price, right, 35. So for Acme, for the firm that did not cheat, the profit becomes, well, they still produce the original 30, right? The other firm produces 40. So they still produce 30, and they get a revenue of 30 times 35. And their total cost, we know they pay 10 for each. So it's 30 times 10. Right? So that's their profit, which is 750, right? 3 times 25, yeah. Okay? So there, you see they're worse off, because in the original scenario, they both got 900. Agreed? When they were colluding. So by Pinnacle cheating, they took away some profits from Acme, all right? They made themselves better off, but reduced Acme's profits. However, what would Acme get? The question is, can Acme also improve on that by cheating as well? So let's see what happens if they do cheat. If both of them cheat, basically. Well, if both of them cheat, we know that, well, let's say they both cheat by 10. So they both produce 40, so we are at 80. Agreed? Right? And they share the profits equally because they have the same costs and revenues. So they get 1,600. Meaning that each of them gets 800, right? So for Acme, the analysis is if the other guy cheats, but I don't, I get 750. If the other guy cheats, but I do as well, I get 800. So they have an incentive to cheat as well. Does that make sense? Yep. All right. So answer here would be C. All right. Now, again, on the same cost structure, if this industry had, instead of being oligopoly, it had many perfectly competitive firms, what would be the market price? All right, think of the outcome in a perfect competition. You have many firms. What kind of profits do they get? Yeah.
Oh.
Yeah, we're not going to do that one. In perfectly competitive market, what's the profit in the long run? Zero. So if instead of having just two firms, we have that cost structure, but we have perfectly competitive firms, each of them is going to get a profit of 0. And where does that happen? At what price? Well, profit if you continue calculating it, right? Here, at that point, which is at $10 correctly, at $10 they make zero profit. So we know if it were not the case that this is an oligopoly, right, where the outcome is not optimal because they charge more, we know what we get is the perfectly competitive outcome of zero profits, and that's going to happen at a price of 10. Do all of us see that? All right, so let's, if I keep calculating profits, right, this is something positive, this is 1,000, this is 550, and this is 0, and this is something negative, and this is something negative. Correct? Perfect competition, the outcome is everybody makes a profit of 0. So outcome of perfect competition is that scenario here. The question is what would be the price if it were perfect competition? And the price we see would be 10. All right? Okay, so the answer is C. All right, question 20. Erase that. I know, yeah, we did. That's fine. It's too elaborate. We don't want to do that. You're not going to have it on the final. All right. This is unrelated to anything. Just marginal cost is given by this equation. What is the variable cost of producing 10 units? All right. So what do we know about variable cost? It is the area below marginal cost curve up until the quantity. So if I were to plot that marginal cost curve, what would the intercept be? What is the intercept? 5. It's a line, right? A straight line, so I need just 2 points. Well, I'm asked what is the variable cost at 10 units. So let's say 10 units is here. What is the marginal cost at 10 units? Right, just plug it in. Just plug this in, and you get 5 plus 2 times 10, or 25. So I know that is 1 point, and this is another point. So my marginal cost curve I can just draw like that. And variable cost, we said, is the area below the marginal cost up until the quantity. So it's this area. This will be variable cost. Again, you can either calculate, we can separate it into a triangle and a rectangle, or you can just realize that it's a trapezoid. Okay? Let's do the trapezoid way. Variable cost is going to be, again, formula is a plus b over 2 times h. If this is the base, what is the length of that side? That's 25. And this is, I know, 5, correct? And the height is 10. So I have everything. I just plug it in. So it's 25 plus 5 divided by 2 times 10, 150. All right, this is straightforward. That will be answer A. All right, question 21. Okay, we have a table of long-run costs for 3 different firms. And these are total costs. Okay? So the total for at each quantity for firms A, B, and C. The question is which firm is experiencing economies of scale? What's the definition of economies of scale? What needs to happen to have economies of scale? As quantity goes up, what needs to happen? Cost goes down, but what cost? So if you look at the cost here, none of them falls with quantity, right? And there is no such answer. So that must not be the case. Which cost should go down with quantity to have economies of scale? This is definition, guys. Sorry? There's no cost C. I asked which cost is going to go down with quantity to have economies of scale. Costs usually have more than one letter in them. If you want to abbreviate them, sorry? Total cost. So this is our total cost. And as we already mentioned, none of them is decreasing with quantity. And that's not one of the answers. So which cost, again, needs to fall with quantity so that I can have economies of scale? Yes? You not, no, but you're at least we're moving in the right direction. So which cost? Sorry? Average? Total cost. There we go. Good job. So now I need to figure out what's the average total cost for each of the firms at each of the quantities, which is easier than it looks like. And given that, then I would just figure out which one is increasing with decreasing with quantity, and that will be my firm that is experiencing economies of scale. We know average total cost just takes the total cost and divides it by the quantity. So for each firm, I'm going to do that. This will be A, B, and C. Quantity from 1 to 5. All right. So for A, this is 100. This is 50. This is 33.3. This is 25. And this is 20. So is that company experiencing economies of scale? Yes. OK. So right now, we know that this is a yes. So it's either this one or this one. All right. Now let's check B. Well, B gets, what does it get? 100, 100. And what do we call that situation? All right, so what was economies of scale? What is the opposite of economies of scale? As quantity increases, average total cost increases, and we call this the opposite of economies of scale. Diseconomies of scale, okay? And when the cost is, average total cost is constant, what do we call this? Constant returns to scale. Okay. So B does not have economies of scale. It actually has constant returns to scale. So that goes away. And the only possible answer is A. And if you do calculate for C, you will have 100, 150, 200, 250, 300. So it would actually be increasing. So they would have diseconomies of scale. I mean, as you produce more and more, your average total cost increases. All right? So answer here is A. Listening? What are you trying to define? Which of the three? Economies of scale. Generally, what does that mean? I mean, logically, think about it. You've heard that term before, no? Economies of scale. As quantity goes up, average total cost goes down. Right? So as quantity goes up, average total cost goes down. Meaning that by producing more, they can decrease costs. Right? So they're experiencing economies of scale. Question 22. Okay, so we have a scenario. Suppose a market has a demand curve that can be expressed as this equation. Marginal revenue curve, which actually we do not need to have been given, right? Because if you have the demand curve, you can find the marginal revenue curve easily. But we do have it. And then the marginal cost of production is a constant 10. All right, so this is the situation that we're given. What is the optimal quantity produced by a monopolist? Where does the monopolist produce? Where what equals what? Marginal revenue equals marginal cost. Well, my marginal revenue is just 90 minus 2Q. And what's my marginal cost?
10.
A constant 10. All right? Given that, I can solve for the quantity. So 80 equals 2Q. Therefore, Q equals 40. So a monopolist is going to produce 40 units. Any questions? This is one equation, one unknown. No problem there. All right. So answer is C. 23. It's going to be the same scenario. What price does a monopolist charge if it cannot price discriminate? So we know they produce 40, but what's the price that they charge? Do we see that? So basically, this is what we have. We have certain demand curve, certain marginal revenue, certain marginal cost. We know that they produce here, they determine the quantity by the intersection of marginal revenue and marginal cost, right? So that's where we got the 40. But then to find the price, what we do is we go up to the demand curve, right? Not to the marginal revenue, but to the demand curve here. So basically the question here is, once we figured out the 40 quantity, what does the demand curve give us as a price? All right, so just plug in 40 in the demand curve equation. The demand curve equation is price equals 90 minus quantity. Well, my quantity is 40, so my price must be 50. And that's here. So now I'm in this situation. They have 40 production, 50 charging as a monopolist that cannot price discriminate. Okay? Answer would be A. Right, 24, that will be the same situation. What is monopoly profit if fixed costs are 800? Okay? So what do I know? I know that they charge 50, they produce 40. All right, so what's my total revenue for this monopolist? Well, it's 40 times the price of 50, $2,000 is my total revenue. To find the profit, I need to know the total cost, correct? Well, total cost, I know, is the sum of fixed and variable. Fixed, I'm told, is 800, correct? So I know that. So the only missing piece of the puzzle is the variable cost. And we already had a question like that. So what is the variable cost in this case? How can I find variable cost? Actually, my picture is quite wrong in this case. The picture is like that. Right? Because marginal cost is constant 10. Now this is 10. Sorry? Exactly. So again, the variable cost would be just the quantity times 10. So it would be, I know the quantity is 40. It's 400. So my total cost is the 800 fixed plus the 400 of variable. So it's 1200. And my profit, therefore, Now profit is total revenue minus total cost, or $800. Okay? And all those formulas, there's not that many. I mean, they're all logical. Everything average is just the total taken divided by the quantity. Profits is total revenue minus total cost. You know, total revenue is price times quantity. Those types of formulas you need to not even memorize, but you need to intuitively know what they are. All right, it's going to make life easier. When you put down the formula for something that you need to find, then you can figure out what are you missing, right? So what do I need to calculate what the question is asking for? And then you have the given as well. Working with the given and the formula, you can figure out what else you need to do to get the answer. But you need to be familiar with the formulas to be able to do so. All right, answer C. Okay, so again, same scenario. Now there's no fixed costs. What is the deadweight loss of monopoly relative to perfect competition in this market? Okay, so we knew the deadweight loss. You look at the picture, would be, right, so this is the monopoly. This is what they're charging, right? This is what's going on. What would the perfect competitor charge? In perfect competition, what would we charge? Well, here where they intersect, right? So what we need to know is deadweight loss. Deadweight loss would be that triangle, right? So that's 40, right? That's the difference between the price of the monopolist and the price of the competitor. Perfect competition, so this is 40. And what is this? This is the other thing we need to find, right? But we don't really know what it is, but we can easily figure it out, right? So the quantity that the perfect competition is going to produce is going to be the quantity given by the intersection between the demand curve and the marginal cost curve, right? Instead of the marginal revenue, marginal cost intersection as with the monopolist, the perfectly competitive one is going to produce where price equals marginal cost, price as in the demand curve. So basically what I'm going to have is marginal cost, marginal cost equals the demand curve. So marginal cost is 10 equals the demand curve, which is 90 minus Q. From there, I'm going to get the perfectly competitive output, right, production, which is 80. Okay, and then I can calculate the deadweight loss. So it would be the change in price. The difference, the difference in prices between monopoly and perfect competition times the difference in quantities of the two. So now it needs to be the quantity under perfectly competitive firm minus the quantity under monopoly, because I know this is higher than that. Right, so the quantity for perfect competition is going to be higher at a lower price. You can just take the absolute value, it's fine. Divided by 2. And in my case, this was 50. This is 10, so the difference is 40. And this is 80, as we calculated. This is 40. The difference is also 40. Divided by 2, 800. Okay? That will be answer D. We're skipping one, so 27. All right, so now we have this nice table. So we're given basically just pieces of the puzzle, but we are given actually everything we need to fill the whole table. I'm not going to do that at first. We're going to fill just as much as we need to answer the questions. But generally, we can actually answer, like we can fill at any cell in this table with the information that we're given. It's not as hard as it looks. Let's go over it. So first question is, we have a firm, these are the costs, we're given some information here and there. First question is, what are the fixed costs facing this firm? Fixed costs. That's straight, that's obvious, right? They have a quantity of 0, right? So that 0, there's no variable one. And total is 100, right? We know that the quantity of 0 variable cost is 0, right? So there's no variable cost here. And total cost, I know, is the sum of variable and fixed. And if there's no variable, then total must be only fixed at 0, right? Total cost at 0 equals fixed cost. And fixed cost, we see, is 100. So this was easy. This is D. Okay? Now it gets interesting. What is the marginal cost of the 5th unit of output? Alrighty. 5 is there. Marginal cost is here. This is what I'm after. Right. So let's see what I can use. I know that marginal cost is the change in total cost from one quantity to the other. Correct? So can you tell me what total cost of 4 is? Total cost of 4. When quantity is 4, total cost is? It is. I'm just waiting for everybody else to realize it as well. What is total cost at 4? Keep in mind the marginal cost is the change in quantity. So as we move from 3 to 4, right, my total cost is going to increase by 22, because I know the marginal cost of the 4th one is 22. So my total cost would be 200. All right. 200. I'm looking for the total cost, for the marginal cost of the 5th one, right? Now, if only I had the total cost of the 5th one, when there's 5, right? I can just look at the difference, and that will be my marginal cost of the 5th one. Agreed? So if I find what's here, the difference between that and that would be my answer. How can I find what's here? Exactly. So total cost is variable cost plus fixed cost. Variable I'm given, it's 130. And what is fixed? 100. That is constant all the time, right? So total is 230. And marginal, therefore, is 30. All right? B. All right. So again, we have the same. If this firm is in a perfectly competitive industry, what is its shutdown price? Okay. So that's what I meant before when I told you we'll be having a problem like that. We calculated before the exit price, which was the minimum of... No, the exit price was the minimum of average total, right? So this would be the minimum of average variable cost. Right, so I need to calculate variable cost at all quantities and then divide that by the quantity to get average variable. So let's start somewhere. Okay, I start, well, here there's nothing, right? Because at 0 there's no averages, you can divide by 0. Right, so moving to the first unit of production. My total cost was just my fixed cost before, which was 100 when it was 0. I'm also told that the marginal cost of the first one is 50. So what can I say about the first unit of production? Total cost is 150. And therefore variable is, remember I'm after variable, 50. All right. That's fine. What about the second one? average variable cost is 30, so I don't really need to do anything there, right? I mean, I can just, I'm actually after average variable. So here is 50, I can calculate as quantity, variable cost divided by 1. So it's 50, 30. What about this one? Right, so I'm after this. I know that total is 178 for the third one. So variable is 78. This is what, 26, right? The average variable then will be 78 divided by 3. All right. Then the next one, 100, right? Because total is 100. Sorry, total is 200, fixed is 100. Variable must be 100, right? So then variable, average variable would be 100 divided by 4, so it would be 25. As you can see, it's still decreasing, right? I'm going to need it to decrease and at some point start increasing. All right. And here I know it's 130 divided by 5, well, that's 26. So I can stop there. Okay, so what's my shutdown price? 25. Is everybody following? Okay. It's my shutdown price. Well, if I wanted to do the exit price, then I would just, given the average variable, I can easily calculate the average fixed. What will be the average fixed cost? 100 divided by the quantity, right? It's always going to be 100. So I'll just divide 100 by the quantity here, and average total would be the sum of the two averages, all right? And then I'll be looking for the minimum average total. That'll be my exit price. All right? Here I'm asked for the shutdown. The shutdown is 25, which is the minimum of average variable. So answer is C. All right, we're still there. If the firm faces perfectly elastic demand at a price of 50 per unit, what is its economic profit? And we assume that it can only produce integers. All right, so perfectly competitive firm facing a demand or a price of 50. All right, where do they produce? Where the price equals what? Where does the perfectly competitive firm produce? So it's faced with a price of 50. It's going to produce where the price equals the marginal cost. So I need to find where the marginal cost is 50. Well, it's here, but I know that this is because marginal cost in this case is going to start looking like that. Right? So it's going to decrease, and then at some point it's going to start increasing, and I want to be at the increasing part of the marginal cost always. So pretty much, well, I kind of know 50 is somewhere here, and then I have 22 somewhere, and then I have 30, but I'm not sure where that is, pretty much. Right? So I know that the next 50, right, the one that I'm interested in, should come after the 30. So basically, I need to see what marginal cost is here and there to figure out what to produce. Is that clear? Well, what's marginal cost? Let's figure it out. All right, here I'm given average variable of 31. So what can I calculate with average variable? The variable, which is average variable times 6, that's 186. What is total? 286, right? Because it's always 100 higher with the fixed cost. So marginal is what? 56. All right, so I don't need to actually go further than that. It turns out that the marginal cost is 50 somewhere between 5 and 6.
How did you get to 186?
Sorry?
Is 56 has 50?
Sorry, can you come?
286
divided by 6.
No, I'm looking at the, all right. Let's get this straight. Average variable cost times 6, 186. So the total cost is 286, correct? What is marginal cost? It is the difference between total now and total before. All right? So for the 6th unit, the marginal cost is going to be the change in total cost. Right? The change in total cost moving from the 5th to the 6th unit is 56. You were thinking about average total, I think. Right. So, given that I know that, and the firm is not allowed to produce uneven quantities, the analysis is basically between the choices between 5 and 6, but with 6, we know the marginal cost of the 6th one is 56, and the marginal benefit would be only 50, right? That would be the price, because you can sell it at 50. So for the 6th one, it's not worth it for me to produce, right? Because then I'll get 50 for it, but then I need to spend 56. Agreed? So what they do is they produce 5. All right. They produce 5. The question is, what is the economic profit at 5? Well, what is revenue? Total revenue when they produce 5 units is $250, right? It's the price times the quantity, right? We're not looking at this yet. So it's 5 times 50, because we know the price is 50, we know they're going to produce 5. So total revenue would be 250. Now we need to figure out what total cost is. Well, we don't need to figure it out because we know it, right? We already calculated it before. Total cost is 230 when they produce 5. Therefore, the profit, $20. All right? That's A. Any questions? All right, so if you wanted to, we can, as I said, fill in any cell here. We just did the ones that we really needed to answer the questions. Okay. So that's going to be something different. All right, question 31. We have rock, paper, scissors. We have 2 people playing the game, A and B, and we're given their payoff matrix. The question is, how many pure strategy Nash equilibria are there in this game? Remember what I mentioned before about the Nash equilibrium in a game? You're going to analyze from every person's perspective. So we're going to start with A. Then you are going to ask A, what would they do given B's action, right? And you're going to keep B's action constant. Then you're going to do the same thing for B. And whenever they overlap, right? So you can circle the decision in each scenario. When there's an overlap, then there's a Nash equilibrium. Right? That's the way that I do it. And I think it's pretty straightforward. So I'm going to use 2 colors for the 2 people. And when I have a cell that has both colors in it, then that's the Nash equilibrium. So I'm A, right? I'm the one that gets the left number, always. Okay? Question is, if B says rock, what should I say? There you go. If B says paper, what should I say? Scissors. If B says scissors, what should I say? Rock. I'm done with A. Now I'm looking from B's perspective. I'm going to use red. So B, they get the left number, right? Sorry, the right number. B is looking at the first one. So if A says rock, what should I say? Paper, right? Because it gives me the highest payoff of 1. If B says paper, what should I say? Scissors. You see where this is going, right? If B says, if A says scissors, what should B say? Rock. Okay. So how many Nash equilibria are they? None. All right. Does that make sense? All right. So the answer is A. All right.
Now, can we assume that that's going to be like something on the test? Because I saw some other test sample and there was some weird stuff. But it actually was stuff.
Okay. So the question is, not sure what the question is. Are there going to be any weird Nash equilibrium questions on the final? Is that the question?
Harder, in other words, harder Nash.
Harder Nash equilibrium questions. For example?
Like in one of the other test samples, that there was like four different, there was like four different options on each side.
Mm-hmm.
Instead of like 9 boxes, we have 16, and there were multiple things that we got rid of, and then there was also like it was really hard to find.
I get your question. This is the maximum matrix size you will get.
This is it. All right. Cool.
Okay.
Wait.
You won't get 4x4 matrix.
All right. So the question was, would you get a payoff matrix with more cells than the ones that you see right here, which are 9? And the answer is no. The maximum is going to be 9, although even 16 is not hard to analyze as long as you follow the same reasoning. It takes you, the marginal cost of that is an additional 20 seconds probably to analyze it with more cells. So it's not that much harder, as long as you follow the logic, which is exactly the same no matter how many cells you have. Right? All right. All right, question 32. The figure is monopolistic competition. If the firm charges a price of 160, the firm is in what sort of equilibrium? Right. Short run, long run, neither, or either. Right? Those are basically the options. So let's analyze this. We know monopolistic competition. What is the short run equilibrium quantity and price? Probably move to. Short-term equilibrium quantity is 100. All right, we know that in the short run they behave as monopolists. Price is 140, right? So we get the quantity where the intersection between marginal revenue, marginal cost. Then we go up to the demand curve, which is here, and then quantity is 140. So monopolistic competition quantity is 140. Sorry, price is 140, quantity is 100. So the question is, at a price of 160, is the firm in some kind of equilibrium? We know that it's not in short term, for sure, right? Because the short run would be 140 price. So this one doesn't work. And this one doesn't work. So it's either in neither equilibrium, right? Or it's only in long term. What will be the long-term equilibrium in this case? What's going to happen? So first of all, is the firm making a profit or suffering a loss? A loss, right? Because the price is below its average total cost. So there's a loss. So what's going to happen in the long run? This is monopolistic competition. So entry and exit is allowed in the long run. So some exit is going to happen, right? So assuming that this firm stays and some of the other firms exit, what's going to happen with the demand that this firm faces? Shift up or down? Up. Because there's now less producers, right? There's less competitors because some of them exited the market. So there's more customers for me, pretty much. So the demand curve is going to shift up until it becomes tangent to the average total cost curve, at which point I will make 0 profits. But that would not happen at the minimum of the average total cost. That would just happen somewhere here. And I mean, you have to draw it to see it, but it's going to be, I'm assuming, somewhere lower than this. Right, so if I were to draw the tangent, that's kind of, if I were to draw the tangent here, it would be like that probably, or something of that sort. So when you move the demand curve, it needs to shift parallel. The parallel shift in the demand curve up until it touches the average total cost curve, and that would happen, I think, somewhere around here. So it's not going to be. Oh, but even if it is, I mean, even if it is, then the demand curve shouldn't be where it is right now, right? It shouldn't be long-run equilibrium because we're not showing the shift in the demand curve. The demand curve is not where it's supposed to be, in other words. But even if it shifts, I don't think it's going to touch it or be tangent to the average total cost exactly at 160. The answer is none of them, yeah. None of them. All right, 33. Oh, okay, we're in the same figure. Okay, in response to the situation represented by the figure, so we're here. So we know that this is, we know what the short term is, we know what's going to happen in the long run. And the question is, well, this question is basically what's going to happen in the long run. Right. Some of the firms that are currently in the market is going to exit. Should we expect that? Yes, right, because there's loss. Right now, the firms are experiencing a loss. So some of the firms are going to exit in the long run. The demand for this firm's product is going to increase, assuming that that firm does not exit. Right? So other firms exit. There's more customers for me, demand shifts. So at this point, we know it's going to be all of the above. Right? But let's look at the third one. This firm's profit is going to move from its current value towards 0. True? Right? So from loss, they're going to go to 0. So all of them are correct, which will make this an answer D. Okay, back to the figure. What is the markup of this product? That's easy and straightforward. What is the markup of this product? It's a good question. What's a markup? When you're selling it at a price that is higher than your marginal cost. So the markup would be the difference between the price and the marginal cost. And the markup in this situation is, well, we already figured that out, right? So they're producing 100, the price is 140, right? And the marginal cost is, we're given 90, correct? So the markup is 50. Right, so it's the difference between the demand and the marginal cost. All right, answer C in this case. All right, 35. Okay, let me erase this. Okay, 35. Okay, suppose that the firm has only one variable input, and that is labor. Output is 0 when labor is 0. When they hire 6 workers, the firm produces 90 units of output. Fixed costs are 30. Variable cost per unit of labor is $10. Marginal product of the 7th unit of labor is 10. Given this information, what is the average total cost of production when the firm hires 7 workers? All right, so there's a lot of information, but it's really, if you summarize it nicely, it's not very hard to analyze. So what do I have? Let's draw some tables. Quantity. Well, I know when quantity is 0. Well, quantity is 0 when labor is 0. Is that it? Yeah. I have variable costs. Labor, this is in terms of people hired, like the number of workers hired. So I'll put this as number of workers. When you hire nobody, you produce nothing. Your variable costs are therefore none, correct? Your fixed cost is, well, it's always there, right? It's 30. All right? So this is when its quantity is, well, when labor is 0 pretty much. So let's put some dots here and see what happens when you have 6 people hired. Because that's the information we're given. When I have 6 people hired, how many units they can produce? 90. 90. All right. What will be my variable cost? 60, right? Because I'm having 6 workers and I'm paying them $10. My fixed cost is still 30. I'm asked about, so basically if you put a column total cost here, this will be 90, right? However, I'm asked about the average total cost of production when the firm hires 7 workers, right? So what happens when I have 7 workers? Well, what's my variable cost? 70. My fixed cost is 30. My total cost, therefore, is 100. All right. I'm asked about the average total cost, I think, yeah, of hiring 10 workers. So the average total cost is the total cost divided by the quantity. I thought total cost is 100. What's the quantity produced when I have 7 workers? Sorry? Right, because I'm told that, what am I told? Fixed cost and the variable cost, the marginal product of the 7th unit of labor. All right? That means if I hire an additional 7th person or worker, how much is my quantity produced going to increase? And it increases by 10, therefore my quantity produced with 7 workers is 100 units, so my average total cost is 1. Any questions? Excuse me? Right, so the question is, how did I get the quantity when I have 7 workers? I'm told that the quantity is 90 when I have 6 workers, right? And I'm also told that the marginal product of the 7th worker or 7th unit of labor is 10 units. What that means is that if I have 6 people, I produce 90 units. If I hire the 7th one, they are going to increase my production by 10. That's the marginal product. Right? This is what it says. The marginal product of the 7th unit of labor is 10. So that way, sorry. So moving from the 6th to the 7th unit of labor, I'm adding 10 units of production, and that brings me to 100, and then the rest of it follows. Yep. Question is, how did I get 70? What is the variable cost of, well, what is the cost per unit of labor? 10. All right, it says here the variable cost per unit of labor is 10. And how many units of labor do I have? 7. So my variable cost will be 70. And then I have the fixed, that is 30 always. That brings me to a total of 100. Any other questions? All right, so answer is D, is it? Yep, D. All right, so let me erase this. Okay. All right. So we have this this cost structure. What type of firm does this figure most likely represent? Okay. What is particular about this figure? What can you notice that is usually not the way we draw it? What seems a bit weird? So the demand curve is where it's supposed to be. The marginal revenue curve is as usual. Right, the cost, what is happening with the costs? They're decreasing with quantity. Right, what did we call that? Sorry? It's a natural monopoly. And what did we call the fact that average cost is decreasing as quantity increases? They're experiencing economies of scale, right? So because of economies of scale, we have this thing called natural monopoly that arises because basically the firm by itself can produce the good at a lower cost than if there were more firms into the industry, right? Because more firms enter, basically restrict production. When you restrict production, your cost is higher, right? Versus if you just give the production to one firm that can do it because of economies of scale at a lower cost. That produces a natural monopoly. So that here is a natural monopoly, which is answer D. 37. Lobsters. All right. So there are 1,000 lobsters. There are 10 fishermen or lobstermen that catch them. All right. So the state of Maine does not wants to avoid overfishing. And because of that, they offered the fishermen in Maine $10,000 to be divided equally among them if those 1,000 lobsters are preserved. Right? So there's a benefit if you don't fish. The government's going to give you $10,000 to the group of fishermen, which is 10. So each of them is going to get 1,000 and none of them fishes. Right? Does that make sense? Now the government also penalizes you by reducing that amount by 10 for each lobster that they fish. And so if all of the lobsters disappear, basically you get zero money from the government. Right? That's the situation. Assume that the marginal cost of catching a lobster is $1 and the lobsters sell for $5 in the open market. All right. Given that situation, question is, what is the profit of each fisherman at the symmetric Nash equilibrium? What do we know is going to happen in this situation? They're not going to fish. Then they get 10,000. And everybody's happy. Nobody has an incentive to cheat on that agreement. All right, so let's analyze it. So as you said, when nobody fishes, right, that's perfectly natural conclusion that you can come to. So with no fishing, well, nobody sells anything, right? There's no revenue or costs associated with lobsters because you don't sell any lobsters. The only money that you get is the $10,000 from the government, and you divide them, let's say, equally. So each of them gets $1,000 if no fishing. So if none fishes, or fish, whatever fishes. Right? That's agreed upon. So what happens when all of them fish? Well, what happens is that all of them fish, they get zero money from the government, right? All the lobsters disappear. So the government doesn't give them anything. Each person individually catches how many lobsters? 100. Right? So the fisherman A catches 100 lobsters, correct? They spend how much money to catch them? Well, we know the marginal cost is 1, it's constant. So they spend $1 to catch them, and they sell them for $5. So they make $4 on each, pretty much, right? So basically, each of them is going to make 400. If all of them fish, each of them makes 400. Versus if none of them fish, each of them gets 1,000. Agreed? Right. So which one do you think we're going to arrive at? Now that would be too good to get to the 1,000, right? We know that that's hard to achieve. So if they collude and they talk to each other and agree in the short run, or have some kind of penalty for fishing or prevent fishing for in some way, then the $1,000 outcome would be the best one, and that would be the cartel type of outcome. However, we know that this is pretty much an oligopoly, right? So that's not going to happen. The problem that we get is, well, the question is, once we agree not to fish, I, as an individual person, do I have an incentive to cheat? So let's see what happens when I cheat. So if nobody else fishes, and I do, how many lobsters am I going to get? All of them. 1,000. How much do I make out of each one? $4. So I am gonna get individually $4,000. Correct? So that's when the rest of them are gonna get nothing because the government still gives them nothing because I caught all the lobster, right? Well, it's individually rational to do so because I am making 4,000 versus 1,000. That if I did not cheat, I will make 1,000. If I did cheat, I will make 4,000. So basically, I have an incentive to cheat. That's true for everybody. However, if everybody cheats, then this is the outcome that we arrive at when everybody cheats by fishing. Agreed? So, question is, the symmetric Nash equilibrium derives a profit of how much for each of them? 400.
So is it safe to say that the Nash equilibrium is pretty much when everybody cheats?
Yeah, but in a way that yeah. I mean, let's not go there. Okay, and what is this called? Prisoner's dilemma. All right. Okay, almost there. Oh, we have a nice game here. See, 9. So let's play the game again. Which of the following is a Nash equilibrium? Well, as you can see, we're going to have one this time. So let's do it again. From firms 1 perspective, if firm 2 says X, what am I going to say? C, right? I don't have, I'm firm 1, I don't have the option Z. I'm firm 1, I can choose from A, B, and C. If 2 says X, I go with C, because that gives me 7, which is the highest. If 2 says Y, B. If 2 says Z, C. All right, and from 2's perspective, well, 2 doesn't need to even analyze what if 1 says A, because A is never an option for 1, right? But, so if they say B, which one do I go with? Z, right? Because now I'm looking at the right ones, and the highest is here. And if 1 says C, what is 2 going to say? X, right? Because that's 6 versus 5 versus 3. They want 6, so they're going to say this. So, yep, which one is it? CX, which is this one.
What happened when firm 2 said Y?
Sorry,
What happened when firm 2 said Y?
when firm 2 said Y, and I'm firm 1, right? I'm going to say, which color did I use? No, wait. Yeah, I'm going to say B because B gives me the highest.
Oh, okay.
Right? Because I'm comparing down, like the vertical. All right, so 1 Nash equilibrium at C. All right, 40. Okay, so we have a lawyer, Alec, who was earning 200K in a law firm. He decides to open his own business. He's cashing in a $100,000 bond that was earning 10%. He also borrows additional $100,000 and pays 10% on it. He hires a paralegal for $100,000 per year, and his rent is $100,000 per year. How much revenue does he need to earn in a year in order to make 0 economic profits? So basically, how much are his economic costs? right? And if he makes that much revenue, he would make zero profit. Economic costs include everything, right? Opportunity costs are there as well. So what is my first cost that I have? His opportunity cost of earning that salary if he were not into that, if he did not start his own business, he would make a salary of 200,000, and this is opportunity cost. Then what else is there? 10% on the, so he cashed in the bond, right? So he's not earning that 10% anymore. So that's also an opportunity cost. This is interest lost. 100,000 times 10%, which is 10,000. That's also an opportunity cost, correct? What else does he have? Right, so he borrowed money and he pays 10% of them. This is general accounting cost, right? So this is interest, 100,000 times 10%, again 10K. This is not opportunity, it's accounting cost, right? That accountant would put that into the income statement as well. What else is there? Hires a paralegal, accounting cost, right? So what is this, labor basically? 100K. And then rent, right? And that's pretty much it. Rent is also 100K. So the first two are opportunity costs, the other one are accounting costs.
I have one question.
What is the question?
Regarding the 10% he cashed in on the 100,000 bond.
Mm-hmm.
So the 10%, we're going to put that in there. But how about the 100,000? Did he use it in the business? How do we know?
No, but it's right. So the question is, what about the 100,000 that he did not keep in the bond investment, right? Why is that not a cost? Because that's not a cost because he was not using that money anyway, right?
Just use the interest out.
He was, that money was generating interest for him.
Oh, so that's the loss. Okay.
And he's still gonna get it eventually, right? And he just got it early. The $100,000 principal he was going to get when the bond expired. So he got it now, and he still got it, right? It's not like he lost it. However, the interest on it is lost. Because instead of keeping it there and getting that 10% each year, now he took it out and loses basically that 10% each year. Okay, so what we have? 200, 3, 4, 20. Correct? 420. So he needs to make 420,000 in order to break even in an economic sense.
Which 100,000?
Sorry?
Which 100,000?
There's 100 for labor, 100 for rent, 200 that he could have made in the law firm, and then 20 from interest.
What about the money that he borrowed? We're not using that.
No. That's not part of the cost. All right. So now we have the 3 extra questions. They're pretty straightforward. So I think we've seen actually one of them before as well. Do you have any questions so far? How's it going? It's making sense?
I still have one question in regards to the last one. Why are we not using the other 100,000?
Sorry?
Why are we not using it as part of the cost?
Which one?
The one that he got from the bank.
The one that he got from the bank, because he got, how is that a cost? He got it, so it's actually a cash inflow, right? And he's going to return it. So it's just the cost associated with it is the interest. Borrowed money he returns, but he gets them and then he returns them. The problem is that he pays interest on them. And that's the cost that we account for. All right, so we have willingness to pay. There's a town, and there's 3 residents only in it. They're trying to determine how large they should build a public park. This table shows us each resident's willingness to pay for each acre of that park. Okay, so this is kind of the benefit that they're going to get from each acre of the park. Suppose the cost to build a park is $33 per acre. How many acres is going to maximize total surplus from the park? Right? This is a general benefit versus cost analysis. Okay? We know that each acre is costing us $33 to produce. The question is, when does the benefit of getting that additional acre becomes lower than the cost of building it? Okay? So the total benefit of the first acre, what is it? Well, that guy gets 30, that gets 18, that guy gets 14. So it's 50, 60, no, 50, 62? 62. All right? So society gets a benefit of 62 out of building that first acre. And it costs us $33 to do so, right? So should we do it? Should we build the first one? Yeah. So the second one gets us, well, as you can see, their willingness to pay decreases. So we have, what is this, 30, 40, 50. Okay, the second one gets us additional 50. And it costs us how much? Still 33, right? That's constant. So should we build the second one? Yeah. The third one, 22, 32, 38. All right? Still higher than the cost of 33. So go for it. Fourth one is 1028. All right? So now basically what happens is at the third, as I am building the third one, I'm analyzing it. If I build another one, society, which consists of those three people, is going to get $28 benefit, right? However, it's going to cost me 33 to build that fourth one. So I shouldn't do it. So I should stick with whenever the benefit is higher than the cost. Right? This is marginal benefit, marginal cost analysis. That's all there is to it. And I should stop at the point where, you know, the next one is going to bring me more costs and benefits. So the answer would be 3. Right? So they should build 3 acres. The park should be 3 acres large. Right? So that will be answer B. This one you've seen before. I think we've done it as either homework or something, some of the other exams, but let's just quickly go over it anyway. So we have firms, they're polluting, right? We have the cost of eliminating units of pollution, right? And this is like a marginal cost thing. So the first unit, to eliminate the first unit, firm A is going to spend $60. Then to eliminate the second unit, it's going to spend $70. In total, they're going to spend $130 for the first 2, right? That's the type of analysis that we have here. So if the government charges a fee of $74 per unit of pollution, how many units are going to be eliminated altogether? Right. So they can either pay 74 and pollute, or they can eliminate pollution. So for firm A, let's look at if they start with the first unit. Is it worth it for them to eliminate the first unit or to pay for it? Eliminate it, right? Because it's cheaper for them to eliminate it than to pay the $74 price of not eliminating it. What about the second one? Eliminate. The third one? Pay for it. So they're going to eliminate 2, right? The first and the second. The second firm, they're going to eliminate how many? Because for them, only the first one is worth it. C is going to eliminate
2.
the first 2. This is not worth it anymore. And D, 2. So in total, which is A? 7 units in total. All right, last question. Discriminating monopoly, that would be easy. All right, concert. 2 types of concert goers, the die-hard fans and the casual fans. for that particular concert, $1,000, 1,000 people are willing to pay 150, and 500 are willing to pay 50 for a ticket. All right, that's the analysis we have. There are 1,500 seats. The cost of putting on the concert is 50,000. So again, this is like the airline example, right? So they have a fixed cost. No matter how many people attend the concert, they're still going to pay 50. The question is, how much additional profit can the concert promoters earn by charging each customer their willingness to pay, relative to charging at a flat price of 150? So now we're told that the base scenario is them charging 150, which means them only capturing the die-hard fans, correct? So basically, the total revenue in the base case would be the 1,000 die-hard fans, which are going to get charged 150 minus the 50,000 total cost, correct? And the total revenue when we are discriminating, what are we going to charge when we are discriminating? Well, we're going to charge those guys what we initially charged them, but we're also going to charge the 500 other fans 50. Do you see that? So there's the 500 casual fans that are only willing to pay 50, so we're going to charge them that, right? Then the rest of it is basically the same, okay? Because we still charge 150 the die-hard fans, and we still only pay 5,000. Put prices. All right. So the question is, how much more? Well, what is the additional profit? Well, additional means, well, since those two are the same, then the additional is only that part, right? Just capturing the other 500 ones with the lower price, because we can price discriminate. So what is that? 25? There you go. All right, that's question. Any questions? All right, guys. Good luck on the exam. So we're not going to have any sessions anymore. That's the last one, obviously. This is the final review. Yeah, well, thank you for the lovely semester, and good luck on the final.